this presentation, we are going to bring all the technology we learned together and see how security is applied in a 128 router. That's what we're going to do here. So you know that from today morning, you learned that we are session aware. We keep track of every TCP and UDP session. Our data model provides hypersegmentation, and we do what's called a secure vector routing, right? If we put all that together, you actually get a network firewall for free. So basically, we have all the things, all the features what a network firewall does. We do that at every session level, every layer 3, layer 4 policies, right? The DOS protection, DDoS protection, IDS, IPS at layer 3, layer 4. We do all that thing at the session level. So what we did is that last year, we partnered with ICSA Labs, owned by Verizon. We went through a whole certification process. We got ourselves certified for corporate firewall certification. So we are certified 3 months ago as a network firewall. And we also got PCI attestation. What we did is that in addition to the ICSA firewall certification, we got PCI attestation to prove that our product can be deployed in a network to get PCI compliance, right? And the next thing we did is that we actually got FIPS 140-2 level 1 certification. We got this 3 years ago. Now, given the fact that we came from Acme, we sold a lot to the federal government, and we learned that FIPS 140-2 was a requirement there. And so right from day one, when we designed the product, we made sure that we put all the required features to be FIPS compliant. So we were able to get the FIPS compliance in 6 months because we already had the base features built in. So as I said, we are a layer 3, layer 4 network firewall. Now, when we started selling our product, people asked us about layer 5 through 7 protection, right? Next generation firewall features. Given the fact that we are a router, we want to focus on layer 3 and layer 4. And what we did is that we partnered with Palo Alto and Zscaler for next generation firewall features. So let's talk about Palo Alto. We have 3 different deployment models for Palo Alto. I'm going to build this slide. First is that we can run as a VM on a single device, on a single bare metal with the with the Palo Alto firewall. We will do service function chaining. We can actually service function chain with a bare metal, with a hardware-based Palo Alto firewall. We can also create a IPsec tunnel with a global protect, which is the Palo Alto's cloud-based firewall, right? Now, the beauty of our solution is that we are service-centric. We know exactly. So what the administrator can do is that for this particular service, I think we need a next-generation firewall treatment. And you route only that service to Palo Alto, right? Every other service will just go through the layer 3, layer 4 firewall treatment. Only services requiring, for example, guest Wi-Fi, right? In the case of a hospital, right? You say that anything on the guest Wi-Fi, I want it to be routed to Palo Alto because I want to make sure that it goes through a next generation firewall treatment. Everything else, 128T router can handle the layer 3, layer 4 firewall, can route based on the characteristics of the service. So that's what we do. We do service-based steering of traffic to Palo Alto. Any questions on this? So with Palo Alto, right, as I said, you get tunnel-free SD-WAN, you get zero-trust security. I'll talk more on zero-trust security. You get per-service next-generation firewall, and we provide both the cloud-based as well as bare metal or service function chaining-based security. We also partner with Zscaler. Again, for Zscaler, we create a dedicated IPsec tunnel. Again, we are not against IPsec. That's the reason we create IPsec, right? So we support both SVR and IPsec on need basis, right? So we create a dedicated IPsec tunnel with Zscaler, and we do the exact same thing we do with Palo Alto. Based on the service and based on your policy, we'll route the packet to a Zscaler firewall. We have multiple deployments with Zscaler going on right now. We get the exact same benefits as Palo Alto partnering with Zscaler. Now, if you think about...
Sorry, could you talk about how a packet goes to Zscaler and then back onto the path?
So the model is that for the services requiring next-generation firewall treatment, what we do is that we identify the packet, and we put that through the IPsec tunnel, goes to the Zscaler firewall, and the packet goes out from there. And on the return path, the packet will come back to Zscaler because they act as a proxy. And then we route the packet back, and then Zscaler will route the packet back to 128.
So at the origin point, that first waypoint, it can say Zscaler is a hop in this path.
That's it. So what we do is that we made it very seamless. Lane, who is going to present with me later, we actually worked with Zscaler. We made it completely seamless. You create a service saying that this particular service requires Zscaler treatment, and we will automatically create. We have what's called as a plugin, a Zscaler plugin. We will automatically instantiate that plugin and create IPsec tunnel to Zscaler. So it's all service based. Now, if you look at, so this is based on the Computer Security Associates statistics. 60 to 80% of the attacks come from the insiders. If you think at the way people build traditional network, right? You have a trusted and an untrusted zone, right? You put a firewall or a next generation firewall at the edge of your network. Everything outside the firewall is untrusted, and everything inside the firewall is trusted. But once you get access to the trusted zone, right, you almost have access to everything happening within that network, right? If you look at the target attack, right, that's exactly what happened, right? The HVAC vendor was given access to the trusted zone, and he was given access to the trusted network. And hey, once he's in, his computer was infected, and all that spread in the target network, and that's how the attack happened, right? Because of which, right, people are advocating, so this is trust versus verify. That is the trusted versus untested zone, right? The new model in which people want to deploy network is verify but never trust, right? That is the zero trust security model. Now, you have learned everything about our data model, right? We do segmentation based on tenants, services, and the policy associated with those tenants and services. We also do encryption and per packet authentication based on the tenants and services. And every session goes through a network firewall treatment, right? Given all that features we have, the advantage of deploying a 128 network is that 128 router is that you get zero trust security by default. So I've highlighted 6 of the features which makes us, once you have 128 router in the network, it makes the network a zero trust secure network. And I'll walk through this. You have heard most of this already, but I'm just going to spend like a few minutes on this. So the 6 features we're going to talk about are deny by default, right? So as I said, 128 router, the default policy on 128 router is deny by default, right? Unless you have a tenant and a service configured, we are going to drop the packet, right? Unlike any other router where the policy is allowed by default, right? In the case of a regular router, you get a packet, you look at the forwarding table, and you forward the packet to the next hop. In the case of 128 router, unless there is a tenant and service policy, right? We're going to drop the packet, we're going to audit log the packet. So, because we are a network firewall, right? So every packet where we cannot create a session, we're going to audit log the packet. So that's our policy, deny by default. Hop by hop authentication, as you have heard in the morning, right? Every 128 router, every session goes through a HMAC SHA-256 per packet authentication. So we provide hop by hop authentication. We provide adaptive encryption. I've seen people tweet about this. So you have heard about adaptive encryption, where if the packet is already encrypted using HTTPS or IPsec, we will not re-encrypt the packet, right? So that's built into the product. We do. We have a distributed firewall. As I said, we have a network firewall built into the product at every router. The beauty is that once you put 128 router, right, it's all segmented. And if there is an attack in one segment, it's contained within that segment, because there is no route from one tenant to the other unless you give access, right? So that's the beauty of it. The attack is contained within that segment. We are hyper-segmented. We have encryption built in with every tenant and service. And the encryption policy is specified per tenant, per service. All the encryption and per packet authentication keys are specific to a tenant, right? Very beautiful solution for a hospital or a financial network, because it's completely segmented and attacks are contained within that segment. I don't know why that's... And we have spoken about the conductor, right? Centralized policy management, where you can manage all the routers from a single point, and all the audit logs we generate, all the routers. Let's assume that a conductor has 1,000 routers, right? All the audit logs generated by every router can be observed from a single point on the conductor. We spoke about the data model, right? Where we have tenant and service model. The default policy is deny by default. When a packet comes in, if it doesn't match, if the local prefix of the packet doesn't match the tenant, we're going to drop the packet. And if the local prefix matches the tenant, right, the next thing we do is that we see whether the destination of the packet matches the service. If the destination of the packet does not match the service, we drop the packet. If the destination of the packet matches the service, then we do all the, we match per service, per tenant. You can configure a security policy, service policy, or an access policy, right? Based on the policy configured, right? If you have a security policy saying that every packet going between two 128 routers should be encrypted, we're going to encrypt the packet. If the service policy says that for this particular application, I have a strict SLA requirement, I want 128 router to take a path which meets my SLA requirement, we'll apply that service policy, and the access policy says exactly who can access the service, okay? Now, if you look at the data model, right, one important thing to note here is that everything is based on the IP prefix, the source prefix. That's how you determine which tenant you belong to, right? So we had a lot of customers asking the question that how do you make sure that you attach it back to the user identity, right? The model we are doing right now is that we are partnering with multiple vendors. For example, we partner with Genius, right, who provide network access control. And what we do is that, given the fact that we are REST driven, right? We have REST APIs. Whenever a user is authenticated into the network, Genius is a NAC vendor. So what they do is that they do ARP poisoning, and when the user authenticates, right, they will authenticate the user with the Active Directory. And what they do is that they send a notification to us saying that user Prashant is authenticated. He belongs to this group, which corresponds to our tenant, and they tell us the IP address. So we dynamically add the user Prashant into the network. We are partnered with Genius. We can do the same thing with Forescout. We are not partnered with Forescout, but it's as easy as writing a small script, right? Because we are completely driven by the REST APIs, and you can write a Python or a Perl script, and you can actually make sure that tenant and services are dynamically created using everything you have learned from the NAC. We use Carbon Black here in our for endpoint protection, and what we do is that Carbon Black has a cloud-based API, right? So we have a Python script we have written where we go to the cloud, we get all the information about the user, the IP address, the tenant the user belongs to, the group the user belongs to, which services the user is allowed to access. All that information is collected from the Carbon Black cloud-based database using an API, and we program tenants and services dynamically using the endpoint protection vendor. The third option we have is, let's assume that most of the Microsoft Windows-based applications use Kerberos, right? You can write a script to observe the Kerberos exchange, and based on the Kerberos exchange, you can actually dynamically learn the domain, the IP address, and the user the user belongs to just by observing the Kerberos exchange, and you can program that dynamically into our product. The point I'm trying to make is that it's very extensible. It's the tenant and service combination is not just based on the IP prefix. You can provide identity-based routing just by writing simple scripts and integrating with your existing NAC vendors, integrating with your existing endpoint protection vendors, or your Kerberos authentication. Okay? Any questions on this?